Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
So I feel like there's some innate information that we need to think about when it comes to triangles, but there's so many inequalities that we may not be bringing to a foresight until somebody points them out. And by inequality, if you remember maybe in junior high or elementary, you would have talked about the alligator symbols, or greater than, that's less than, sorry, or greater than. And that's what we're talking about as inequalities in a triangle. So for example, I'm going to try to make this very obvious here. A, B, C. I think it's very obvious to anyone looking that AC is the longest side and angle B is the largest angle. And a lot of times whenever we are working with math stuff, because this is a capital B, it opens up to this side because that's how wide the mouth is open. If you look at the top of the mouth and the bottom of the mouth to connect the sides of the mouth, we'd have to connect this part. So those things are related. So it's no surprise that angle B and side AC are both the largest here in this case. So since that's A, this would be lowercase a, that's C, that's lowercase c. So what if I told you that side AB was the next largest? Well, if this is the next largest, then that means that would have to be the next largest angle. And if I told you BC was the smallest, B to C is the smallest, then that means angle A has to be the smallest angle. So if segment AC is greater than AB, which is greater than BC, then angle B has to be greater than angle C, which has to be greater than angle A. And that's why I start putting the marks through my angles. That way I know the difference between an angle symbol and a greater than, less than symbol. Okay. So it's really important to just know that the biggest angle corresponds to the biggest side. And to highlight that, if I tell you angle A is the smallest, here's one side of angle A, here's the other side to angle A, right? So those are the parts to angle A. So that's why it corresponds to this side, because that's how far it goes from the green pen to the brown pen, which is what I mean by connecting the mouth, quote unquote mouth, like you open and close the alligator mouth. Okay, so I'm just going to give you a triangle. It's going to have some information in it, and I just want to know what side is the longest. And it's not necessarily going to be drawn to scale because I'm infamous for just throwing a triangle down without paying attention to the numbers that I'm thinking of using, and then I throw out the numbers, and the triangle does not look like any of the numbers that I'm looking for. We've got a 58 degree here and a 64 degree here. Which side's the longest? Well, we first need to know the third angle, right? So if you recall, our triangle angle sum theorem says that triangles add up to 180. And I know it sounds a lot like saying triangle angle sum, but that's the proper word. Sum of the angles of a triangle. So 58 plus 64, we're already at 122, which leaves 58 degrees left for the last one. Oh, well, this is interesting. Which one's the longest? Well, since this is the biggest angle, that's the biggest side. Well, which one's the shortest? Well, there's a tie for shortest because they have the same angle twice. So that's kind of what we're thinking about. So that's one thing to keep in mind, is that eventually you're going to be solving for parts of a triangle, and just knowing that the biggest side has to go at the biggest angle, the smallest side has to go at the smallest angle is a really, really big tool to have in your pocket. the angles like that corresponding are not the only inequalities we see in a triangle. So I have some things lying around here. I have this little key. I have this. Now we're going to go with the blue strip that I have here on my little lanyard. Okay. Go ahead and make it bright. Now you can tell that it is blue when it's in the light, but hey. I want to use this cloth here, this little thing here, and this thing here to make a triangle. Can I do it? It doesn't seem to be working very well. Maybe? Maybe? Okay. Well, let's see here. We're going to pop some grid paper over here. Let's get even more detailed. So we're going to have one side that is 3 squares long, one side that is 1, 2, 3, 4 squares long, and I want to do that combined with one that is 9 squares long. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I want to use those 3 sides and I want to make a triangle. Okay, so I'm going to start with mine. Well, actually, I can just count 9 squares. That's not going to be very hard. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And I'm going to measure my length of 4. Get this in here faster. Okay. I drew an arc that long, right? And 3 is even smaller, so come in even more. Where can I put my 3rd point? Like, my length of 3 is going to come in from this side. My length of 4 is going to come, well, I guess I drew them backwards. 4 on the left, 3 on the right. And they're not gonna come together. Okay. What about 3, 4, and 6? So I still have this set for 3, so I'm going to keep it. I'm going to do my 3 first. Open it back out to the 4. Hey, they are going to come together this time. They're going to come together right here. So why could I do 3, 4, and 6, but not 3, 4, and 9? Well, here's why. With the 4, we were trying to see how they're not long enough to touch in the middle. So your 2 short segments always have to be more than your 3rd when you add those segments together. Otherwise, I mean, you can't even add these 2 segments together to make the long base. So your short plus your middle has to be more than your longest. Otherwise, you can't physically make a triangle. And you could test that with other ones. I just kind of used the grid paper to help us see it, and then I used my compass to copy a segment over. So that's a really key way of checking if you're not understanding something, to think about it. So your short side plus your middle side have to always be longest than your longest side. Longer than your longest side. Okay, so if I tell you that you have a 30-inch long side and a 50-inch long side, how long could your other side be? What are the restrictions to side 3? Well, that all depends. Okay, so remember I said short plus middle have to be bigger than your long. Well, here's the thing is we know 30 is smaller than 50, so it's either the shortest or the middleest, but we don't know if 50 is the longest or the middleest. So short plus middle has to be more than long, or short plus middle has to be more than long. Okay, so when I solve this, subtract 30, x has to be more than 20, add those together, but smaller than 80. Okay, so x has to be between 20 and 80. So your third side has to be between. If it's in, oh, it does say it's in inches, so we should label in inches. So just knowing whether or not a triangle could even exist could actually help you do some math problems. But that's kind of a nice little catch there, that you know that your two shorter sides have to add up to more than your long. What happens if they equal your long? Well, 3 plus 4 is 7, right? That's basically just putting two lines together and laying them on top in a straight line. So you would have short, middle, and then your long is like going to be laying perfectly on top of them, right? Taking up the same spot. So that's why it can't be equal to. It has to be greater than. Short plus middle has to be greater than your long.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.